Hello everyone. I hope you are fine. Again we are here, our next class, then our fourth unit is going on of class 11th physics. Okay. Then in last class beta we are discussing about their work. Different form of the work is done by any object. Their displacement is take place. So work done during your vector form, during scalar form. If at any angle is acting their force, then how you can find their work done. Okay. So after that work done, we will discuss their energy. What is energy? Their different form of the energy, then how we can divide these energy in a different form. Okay, before this one we will discuss here one topic left of the work done. When body is sliding, in yesterday in last class we discuss here this one work done on the rough inclined plane. We are discussing in last class कि rough inclined plane पे body क्या कर रही है, upward direction में move कर रही है. Okay, so in this case one, then our this one left work done by any body on the rough inclined plane when this one is a moving on a downward direction. Okay, so here we are doing first this one, then we will discuss our energy topic. Now if this one our theta angle, then body is moving on this one plane and this one sliding down. Body कहाँ कर रही है, नीचे की तरफ slide कर रही है. That F force is acting there. Friction on this object will be act in upward direction. If mass of this body is m, let m is mass of an object whose displacement s is take place on rough inclined plane. ओके कि अगर बॉडी का मास क्या है, अगर हम लेके चल रहे हैं देन डिस्प्लेसिंग फ्रॉम हियर टू टिल देयर. ओके, तो यहाँ से यहाँ तक कितना डिस्प्लेस कर रही है बॉडी, एस डिस्प्लेसमेंट कर रही है. तो वर्क डन आपको फाइंड करना है. इन लास्ट क्लास वी डिस्कस बेटा बॉडी इज मूविंग अपवर्ड डायरेक्शन विद एस डिस्प्लेसमेंट, देन हाउ मच वर्क विल बी देयर. सो टुडे दैट बॉडी इज कमिंग डाउन, how we can find this one work done. So your remain same, only direction are changing. उस टाइम पे फ्रिक्शन का लगता है पीछे डाउनवर्ड डायरेक्शन में. नाउ फ्रिक्शन इज एक्टिंग इन अपवर्ड डायरेक्शन बिकॉज बॉडी इज स्लाइडिंग डाउन. सो इफ F means the mass, then weight will be act in this direction, that will be mg. Now in this direction your r will be act there. Now here will be your this one your theta. So resolve these components. Some component will be act in this direction, mg cos theta, and of mg some component will be act in this direction, that will be your mg sin theta. Okay, these components are acting in this one. So how we can find, according to our diagram figure, then here we can write there r equal to mg cos theta. One we can write there this one side equal to this one side. Okay, body is sliding down, so this one component minus this one component equal to our force. Okay, now by using second equation of motion, second law, not equation, second law of motion, that is your Newton's law. Okay, as we know that F equal to your me. So total force we will find. Then don't write F equal to me because there need the total force only, not a need of A. That's why here we are writing this one equation, mg sin theta. This one is sliding down, so this force will be more than as compared to this one force. Okay, so small f क्या आपका यहाँ पे फ्रिक्शन. बॉडी इधर स्लाइड करे तो फ्रिक्शन कहाँ लगता है, अपोजिट डायरेक्शन मोशन. सो mg sin theta minus friction equal to your their force. So force equation will be this one. Now here we can write there, as we know that friction is equal to your mu r, then r we can write mg cos theta. So here we can write this one equation, mg sin theta minus your mu r equal to your force. So force we can write there F equal to mg sin theta minus mu r we can write there mg cos theta. Okay, so from here we can write there mg you can take common, then here left sin theta minus mu cos theta. This one our force equation came out. So here we have to find out work done by this object sliding down. When body object is sliding down on a rough inclined plane, so here we can write their work done equal to, we can write their force into displacement. Okay, we know about this, and work done equal to force into displacement. Given in our question derivation that we have taken that S is our displacement, so put value of F. So put value of F, force value. Okay, after putting this one, then force will be there. Our force is come out this one mg sin theta minus mu cos theta. Mg sin theta minus mu cos theta. This one will be our force. Okay, multiply with our displacement, then this one will be our complete work done during any object is the sliding down on a rough inclined plane. Okay, rough की बात करें तो friction will be there. If rough is not there, smooth is acting there, then we will take there friction will be equal to 0. Then we will write simple equation without friction by using a Newton's second law. Okay, so like this one method we can find their work done on a inclined plane. So now next topic we are starting our energy. Energy beta in daily life that we are using this one here. Energy we are using there. Use of load, there is a different form of the energy we are using. Work done always will store in form of the energy only. Okay, work done unit we discussed there, joule only a unit of the work done. Energy unit also will be a joule only. So you can say how much work is done, that is a depend upon the energy. If having energy, then means work is done. क्लियर, एनर्जी क्या होती है, हमेशा वर्क डन की फॉर्म में स्टोर होती है. वर्क डन हम तभी कर सकते हैं जब एनर्जी होगी. तो हमारे डेली लाइफ में क्या होता है, एनर्जी हम रेगुलरली यूज करते हैं. ओके, डिफरेंट फॉर्म ऑफ द एनर्जी. एनर्जी कैन बी कन्वर्ट वन फॉर्म टू दी अनदर, ऑलवेज फॉर्म इन द कंजर्व्ड. ओके, सो दिस वन इज अ यूनिवर्सल टर्म. यूनिवर्सल टर्म है बेटा, कंप्लीट यूनिवर्स में सब कुछ क्या है, एनर्जी से ही चलता है. ओके, सो वी यूज अ लॉट इन आवर डेली लाइफ. एनर्जी का हम क्या है डेली लाइफ में बहुत ही यूज करते हैं रेगुलरली. सो एनर्जी कैन एग्जिस्ट इन द मैनी फॉर्म, मैनी फॉर्म में एग्जिस्ट करती है. ऑल फॉर्म ऑफ द एनर्जी आर आइदर काइनेटिक और पोटेंशियल. सभी फॉर्म जो है एनर्जी की that will be kinetic either your potential. तो kinetic होगी या potential होगी. Kinetic means related to the motion, potential means to change the configuration. Okay, so here we will check there how many form of the energy. Different form. Electrical energy. Electrical energy means due to the flow of the charges, then energy will be conserved, that electrical energy. Thermal energy, due to the heat, energy will be conserved, thermal. Light energy, photon will transfer from one to another particle, then we will call it light energy will be there. Wave energy, as wave will be generated. For example, as we are throwing stone in the water, then surrounding there, then waves are generated. आपने जनरली देखा होगा कहीं पर पानी में स्टोन अगर थ्रो करें तो चारों तरफ क्या बनती है, लहर बन जाती है. वो क्या है, आपकी वेव ही है. तो वेव भी क्या होती है, एनर्जी क्रिएट करती है. हीट एनर्जी, ड्यू टू द हीट, देन वी विल कॉल इट हीट एनर्जी. हाइड्रो इलेक्ट्रिक एनर्जी. हाइड्रो इलेक्ट्रिक मीन्स, हाइड्रो मीन्स रिलेटेड टू वाटर, वाटर की हेल्प से इलेक्ट्रिसिटी जनरेट करना, दैट इज हाइड्रो इलेक्ट्रिक एनर्जी. सोलर एनर्जी. सोलर एनर्जी जनरली नाउ these days we are using solar energy. सन की लाइट में की प्रेजेंस में हम इलेक्ट्रिसिटी क्रिएट करते हैं, दैट वी आर कॉलिंग इट सोलर एनर्जी। मींस सन की जो लाइट है उसका यूज करना है हमारा क्या, सोलर एनर्जी। सो विंड एनर्जी, विंड ड्यू टू इन प्रेजेंस ऑल्सो विंड, देन वी आर यूजिंग देयर इलेक्ट्रिसिटी, तो विंड एनर्जी का भी हम यूज करते हैं। न्यूक्लियर एनर्जी ना, न्यूक्लियर पावर प्लांट वी आर यूजिंग दिस वन। टाइडल एनर्जी इन सीज, टाइडल एनर्जी कहाँ जनरेट होती है, सीज के अंदर जनरेट होती है। सी के अंदर लहर आती है, उनकी हेल्प से क्या निकालते हैं हम, टाइडल एनर्जी जनरेट कराते हैं। बायोमास एनर्जी, बायोमास एनर्जी ड्यू टू द dung of the animals, then we are creating their biomass energy. Kinetic energy, geothermal energy, kinetic due to the motion of the objects, then generate their kinetic energy. Geothermal energy, geo means your earth, thermal means टेम्परेचर, ओके, अर्थ के अंदर जो हीट है, अर्थ के अंदर से गर्म है, ओके, तो उसकी गर्मी को हम जो एनर्जी के रूप में हम कन्वर्ट करें, दैट वी विल कॉल इट जियोथर्मल एनर्जी, ओके, एनर्जी कंजर्व्ड इनसाइड द अर्थ सरफेस, ओके, दैट इज सो मच हॉट, सो जियोथर्मल एनर्जी, दीज आर द डिफरेंट टाइप ऑफ द फॉर्म ऑफ द एनर्जी विच वी आर यूजिंग इन आवर नेचर रेगुलर यूजेज, ओके। सो we will discuss now what is energy. Energy is the ability to do any work, okay, energy क्या है, that is ability, कोई भी काम करने की कितनी ability है, that will be your energy, okay, if you are having ability then you can do any work, if not then we can't do any work, ओके। लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, लॉ ऑफ कंजर्वेशन ऑफ एनर्जी कहता है कि एनर्जी नाइदर भी क्रिएट नॉर भी डिस्ट्रॉय, ना तो एनर्जी को बना सकते हैं ना क्रिएट डिस्ट्रॉय कर सकते हैं। इट कैन बी ट्रांसफर वन फॉर्म दी अनदर फॉर्म, एक फॉर्म से दूसरी फॉर्म में हम कन्वर्ट कर सकते हैं, ओके। सो लॉ ऑफ कंजर्वेशन, अकॉर्डिंग टू दिस लॉ ऑफ एनर्जी, एनर्जी कैन नाइदर बी क्रिएटेड nor be destroyed but can only be converted one form to the another form, okay। unit of energy, work done unit your joule only, so energy unit also will be your joule only, okay। then unit of the energy is named after the James Priest called joule, okay, after the scientist then energy name is given joule only। then energy is also expressed in the many another unit not a part of SI unit such as erg, this is not SI unit but CGS unit of the energy, calorie, kilowatt hour, kilocalories, these are the different unit of the energy that we are using for measurement of the energy, but these are not SI unit but having different unit। so your question, what is the commercial unit of the energy? Commercial unit, that we are using unit of the energy for a industry purpose, commercially we are using, so kilowatt hour we are using, this one unit we are using for the commercial use of energy, okay। now after this one, different type of the energy, I told you beta that is that energy always will be in two form, kinetic and potential. All form of the energy we are dividing into two part, kinetic energy and potential. Some energy dividing into kinetic, some energy dividing into potential. So kinetic and potential. Your potential, chemical energy, any chemical energy will come in category of the potential. Potential means change in the configuration of the object, that is potential energy. If any body is moving during the motion, that energy will be considered, that is kinetic energy। so electrical energy, potential, elastic energy भी क्या होती है आपकी, potential energy होती है, gravitational energy भी किस में store होती है, potential energy होती है। kinetic energy, mechanical energy, electrical energy, thermal energy, sound, radiate energy, these are the energy or type of the kinetic energy, okay। next our kinetic energy, kinetic energy is the energy associated with the object motion, for example here any object that will be moving on this one plane, then initially its velocity is u, after some time its velocity becomes v, then during the motion of that object which energy will be act there, that energy is known as the kinetic energy। simple way में हम यही कह सकते हैं kinetic energy, kinetic means your related to motion, ओके जब भी कोई बॉडी मूव करती है, मोशन में रहती है, तो जो एनर्जी लगती है उस एनर्जी को हम क्या बोलते हैं? काइनेटिक एनर्जी बोलते हैं. सो दिस वन काइनेटिक एनर्जी, दैट फॉर्मूला वी कैन राइट देयर हाफ mv square. Half mv square. So this one half mv square, initial velocity of this object, let we are taking their u, final velocity v we are taking, m is the mass of this object, then how much energy will be there. Okay, so कहीं भी अगर energy find करनी है, then first we will find their work done, and work done always will store in form of the energy only. So body initially on this one position whose mass is m, moving from here to there, then we will find their work done, कि body यहाँ से यहाँ तक का कितना काम कर रही है, that work we will find there, that work done will give us energy, that is kinetic energy. Okay, so kinetic energy, how we can write there? Kinetic energy half mv square. Then let m is mass of an object moving with initial velocity u and after s displacement. आफ्टर एस डिस्प्लेसमेंट मीन्स इनिशियल वेलोसिटी क्या थी? यू थी. बॉडी मूव कर रही है यहाँ से यहाँ तक, एंड डिस्प्लेसमेंट टेकन बाय दिस ऑब्जेक्ट फ्रॉम हियर टू देयर, एस डिस्प्लेसमेंट. आफ्टर फाइनली इट्स वेलोसिटी बिकम्स हियर v. Its velocity becomes v. So this one here final velocity, then after s displacement is final velocity becomes here v only. So work done we can write there, work done by this object from, let here we are taking a point, this one we are taking b point. Okay, going from a to b, a to b. So we can write there by using your definition we discussed already, work done equal to your force into displacement. Okay, completely beta this one here we can write there in form of the vector, that is your f dot s. We can write this one as you remove this one dot, then always we are taking a cross cos theta, fs cos theta. This one theta is the angle between force and displacement. So your displacement angle we can write there, both are acting, force is acting in this direction, displacement also acting in this direction. So here we can write there theta will be equal to here 0 only. So if theta equal to 0, then work done we can write there fs cos 0. Cos 0 will be equal to here 1. So here work done will be left there fs. That's why here we are writing there work done fs. So right here, as we know about this one, by using your Newton's second law, then we can write there force equal to, by using Newton's second law, F equal to your ma. Know about this one, second law of motion, Newton's second law. So work done we can write there mas. If initial velocity is u, final velocity is v, then your acceleration we can write there, as we know acceleration we can write there final minus initial divided by your t. Okay. Then here need of kinetic energy is equal to your half mv square, but if your displacement will be s, then by using third equation of motion, Okay, here t, there is no need of the time, here need of the velocity and mass. That's why we will replace this one by using your third equation of motion. So here we know about the third equation, v square minus u square equal to our 2as. Okay, from this one equation we can take out a equal to your v square minus u square divided by your 2s. Now, as we have done, your work done equal to your MAS. Okay, then use this one. Then here we can write there. Then work done equal to by using equation 1, then work done equal to your force into displacement, then by Newton's second law MAS. Okay, so by using this one, then put value of A, then write their work done A we can write this one, put value of this one. So write here v square minus u square divided by your 2s, then write there s as it is. So s to s cancel out, then here left here work done will be equal to your m v square minus u square and divide by your 2. Okay, this one came out. Now here need of half mv square means here initial velocity should be 0. So here we will assume let object is initially at rest. Object is initially at rest. कि object starting में क्या है, rest में. That's why here initial velocity you can put there 0. So as we are putting this one u equal to 0 here, then work done will become out 1 by 2 m. Here v square minus here u square we are keeping 0. So here left here half m v square. So work done will store in form of the kinetic energy. Kinetic energy we can write there half mv square. Like this one we can find their kinetic energy. Now after this one we will use the second method of the kinetic energy by using a differentiation calculus method. How we can find this one? So thank you for watching today. Then in next class we will start our next topic.